Find the average and instantaneous velocity. So the question says, suppose that the height of a falling object, t seconds, after being dropped from a height of 64 feet is given by this equation. Find the average velocity between when time is 1 and time is 2. Then the average velocity when the times between time 1.5 and 2. The average velocity between 1.9 and 2, and then the instantaneous velocity at t equals 2. So let's have a look. First of all, we're going to write down our velocity, the average, and this is going to be our function of b minus s of a, and this is divided by b minus a. So our first question, our interval, is between 1 and 2. So we're going to substitute into this our values, where we have a is 1 and b is 2. So this is going to be 2 minus 1 and 2 minus 1. So now we just need to substitute this in for our equation that is given in the question. So we have 64 minus 16. Now first of all we have 2, so this is squared, and then we're going to minus, so we're going to do the function again, but this time with 1. So a 64 minus 16, and that's 1 squared, and 2 minus 1 is just 1. So if we work this out, we will have an answer of minus 48 feet per second. Okay, so that's a negative, so that's because it's fallen. And let's have a look at the second one. So average. So this time we're going to have, so A is 1.5 and B is 2. So we've got 2, 1.5, 2 minus 1.5. And if we write this in, we'll have 64 minus 16, and we'll have 2 squared minus 16 minus 16. Oops, 64, sorry. 64 minus 16, and then it's 1.5 squared divided by 2 minus, it's going to be divided by 0.5. And if you put this into the calculator, we will have minus 56, and this is feet per second. And remember, this is because we have t is seconds and we have feet. Okay, so you can have a go at the next one, and then we'll check. Okay, so you should have the average velocity. So A will be 1.9 and B will be 2. So this is going to be S of 2 minus 1.9. And then B, so we've got 2 minus 1.9. So 64 minus 16, 2 squared, minus 64 minus 16, 1.9 squared, divided by 0.1. So this time we should have minus 62.4 feet per second. So the last part of our question, it asks us to find the instantaneous velocity at t is equal to 2. So let's have a look at this. So this is going to be the velocity when time is 2. So we're going to use the limit as h is approaching 0. And this time we'll use s. And a is 2. So it's going to be 2 plus h. And it's going to be minus s of 2. And this is going to be over 2 plus h minus 2. So we know with this, the 2's will cancel. So we're just going to be left with h. So now we need to substitute into the formula. So we'll have the limit as h is approaching 0. So we have the equation of 64 minus 16, and instead of t, we're going to write 2 plus h, and it was t squared, so this is going to be squared. And then our s2, because our equation we had here, which is 64 minus 16t squared, so we're going to have minus 64 minus 16, and it's going to be 2 squared, and this is all over h. So the limit, h is approaching 0, so we need to expand. So we're going to have 64 minus 16, and then this here is going to be 2 squared, so that's going to be 4. 2 times 2h is going to be 4h plus h squared. And then we'll have 64 minus 16 multiplied by 4. And this is all over h. So the limit as h is approaching 0. So we're going to have 64 minus and 16. So we're going to have 64. So let's have a look what we got. 64 minus 64. So let's do this bit by bit. So 64 minus 16 times 4 is 64. Minus 16 times 4 is minus 64h. Minus 16h squared minus 64 plus 64 divided by h. So this will cancel, this will cancel. So we're just left with minus 64h minus 16h squared. Now we're going to factor by h. So limit is h. So h, and actually we can factor with minus 16h. So let's do that. Minus 16h. So this is going to give us, so we're going to have 4, and this is going to be plus h. Okay, divided by h. So the h is going to cancel. Then the limit as h is approaching 0. So you've got minus 16 minus 16 multiplied by 4. And then, so this is minus 16 multiplied by 4. And this is plus 0. So this is going to be, if we substitute in the value, so we're going to have then the limit as h is approaching 0 is going to be minus 64 feet per second.